That was a really interesting talk. I hope you'll agree. Our next speaker is a very busy man. He wears numerous hats, but his main two are Vice Chairman of Innovation Department of Surgery at Duke University School of Medicine and is Director of the Surgical Artificial Intelligence and Innovation Laboratory. Please put your hands together for Dr. Ozanan Meireles, who is here to share his wealth of experience around AI-powered surgery. Please, Ozanan.
Hi, good afternoon, everybody. So I'm very pleased to be joining again this amazing organization here, especially thanks to Caroline and Sarah for having me here. And without further ado, we're clearly living in an era of technology disruptions, right? Self-driving cars, ChatGPT, quantum computing. That's needless to say. It's almost there is a new Darwinism playing a role in the nation levels and the industries and so on and so forth. But this is also happening in the operating room. To put into context, there was a few revolutions in surgery. General anesthesia was one of them. Then antiseptic techniques came along, allows us to operate on patients for longer times and survive from infections. Then came endoscopic procedures, robotic surgery, laparoscopic surgery, and the luminous surgery. And then more recently, you're living to the cognitive computing that everybody calls AI. And in 2016, a new field was born, was surgical artificial intelligence. And that's being fueled by all the data-driven information that comes from all those devices, software, hardwares, human operators, among others. Well, but what's core of our surgical AI is a surgical video that's being generated, millions of them every day across the world. Much more computing power, much better techniques such as the convolutional neural networks that allow us to see faces better than humans, right? But to make an analogy, and especially coming from a city that hosts the Grand Prix of Formula One, there is so many data points in Formula One that they take into real time, account all of them, for the drivers, for the tracks, for the previous experiences. And this was the data from the Qatar racetrack. What do is they have techniques with the analytics partner companies, such as Oracle of Red Bull Racing, which has air handling and recovering based on what happens in the race in the real time. But it's based on simulation of all the data that's being gathered in the past and during the race. And if you can make a comparison, look at that. Is one hospital can generate 137 terabytes of data per day, and now the 10 teams of the 20 cars, 243 terabytes per day. But what if we could do the same what Formula One does and utilize this type of data in a real time to make a surgical planning? Look at the potential applications of the current technology we have, from data-driven insights to predictive analytics, generating operative reports, doing billings, compliance monitoring, attention awareness. The list is enormous. But there are barriers, and they are all listed over there. The quality of the data, the cost to implement, how complex to integrate different technologies in medicine, which they don't talk, a huge cultural resistance, the limited interpretability of AI that everybody knows that's not just for surgery and medicine, and of course the ethical considerations. So if you look about this curve right now, in 2016 we were of the innovators. Right now we have a lot of early adopters, but we haven't crossed the chasm yet. The magical number is 18% of adopters. And how do we do that? So we have a plan, right? There are three major pillars of development to get to that point. One is, of course, establishing the community, and there's a huge community there. Community here, I want to use this, is establishing a legal framework. There are so many different types of governance that we just have to navigate through. But we still need to build the architectural framework that connect all of them. Over the last several years, on my other hat, I'm the chair of the Artificial Intelligence Committee of SAIIL, which is the larger surgical society and minimally invasive in the world. We created those pillars about development. We have done foundational work about creating standards, our structural needs, understanding what's the technology we need to acquire, and disseminating our knowledge, and also working with cultural transformation. We have to be treating a surgical video like we treat a specimen. If the specimen goes to the GR and goes to pathology, the surgical video goes to USB and go to the cloud to an AI lab. We have to understand that the surgical data is very complex. The surgical data would never exist wasn't for the combination and the interaction of all those stakeholders. And the use of the data is also regulated by local authorities to governmental ones to continental ones. So it's very complex to understand this. Through SAIIL, what we did, we created a few standards for surgical AI. One was the consensus for annotation of the surgical video. And if you can look over here, there are two different types. You have the temporal effects, and you have the spatial ones. One is talk about the actions and the tasks and the steps of the operation. And the other ones talk about the anatomy, the tissue characteristics. Another way to see this is that you can actually decompose a surgical procedure, deconstruct a surgical procedure in small little Lego blocks as far as how the actions happen. And similarly, you can do for the anatomy. So imagine a sequence of actions becomes tasks. A sequence of tasks becomes steps of the operation. That becomes the entire surgery. That's how we can teach machine. And similar for the anatomy, veins and muscles and fat together becomes a particular organ. We also standardize the standards for the surgical video structure, use governance and exploration. We found more than 20 use cases that can be leveraged just by the utilization of surgical video. And also we map the data through its life cycle. And it's important to notice that different parts of the life cycle of the data have different stakeholders involved. It's not like in one single point that's going to be all of them or just one of them. And then how do we build a community? Through scientific efforts, discovery, validation, and benchmarking. And talk about benchmarking, this is so important because this helps us to understand what's not explainable and how we can deviate from standards of AI. So along with Formula One, who benchmarks, we decided to do our one, a computer vision competition for model benchmarking. It's almost kind of like our own Grand Prix, our own challenge. And it's based on something that's called the Critical View of Safety Challenge, which I'm going to go explain what it is. A computer vision challenge, for the people who don't know here, is when you get a bunch of classifiers, pictures, videos, and then you label them, and then you release them to developers to get the accuracy. ImageNet was one of the most famous ones, 2016, when the convolutional neural networks came about, and that's why we can unlock our phones of our faces. But now we are doing for a component of an operation that's removing the gallbladder, that's called the critical view of safety. If you achieve this view that you are seeing there on the up screen right there, the likelihood of having complications is extremely low. So we got more than 1,000 videos, actually close to almost 2,000 videos from all over the world, from different donors. And then we created this challenge, right? There was more than 10,000 people who visited the website to learn about what's a safe cholecystectomy. We created a group of organizers, both scientists from medicine and data science. And then we have a lot of support. And see how it's building the community. They have support for the data donors. 24 countries donated data. We have advisors and also financial support from the big tech companies for surgery. And you have annotators, people who are trained to annotate the data. We then were able to develop the most diverse and largest data set in surgery for computer vision challenges in the world. Then we trained this for several different factors, including taking into account for uncertainty where you're seeing, and how robust were those models to understand different types of techniques in different parts of the world. We released that data set. It was 36 teams and 16 countries participating on that. And in Mikai, in October, in Marrakesh, we announced the winners. That's the list of the teams who won, the top 13 over there. And of course, like have number 1, number 2, and number 3, which receive a prize for participating in this. So what we did here was like we did benchmarking. At that point, we were invited by Mikai to participate in the Lighthouse Challenge in South Korea for this coming year. Besides this, education and training is fundamental for that, because without making people understand what's artificial intelligence, how they can use it, and how can critically assess it, it doesn't go to the next level. We have a dedicated fellowship for both clinicians and technical folks. We are going to be soon releasing some public data. We already have something on GitHub, but people can access data sets from surgery, including some tools to try training AI models. We are growing the network. Now, SAIIL is present not just at Duke, Mass General, but also in Rotterdam, in the Netherlands, Singapore, Duke, and US very soon, one of our partners, and Cologne in Germany. Understanding surgical governance is something that's super important as well, because when you think about who does the data belong to, who can use the data, what are the reasons for the use of the data, All those stakeholders need to be in the table. And then, of course, responsible AI, ethical AI. More recently, SAIIL has partnered with Train, the Trustworthy Responsible AI Network, which has more than 40 health systems in the United States and 9 in Europe to promote responsible AI. So then what brings us, right? Going back to the graph that I showed that we need to cross the chasm is gigantic, right? And we need a blueprint to build this bridge to cross the chasm. So what are we doing? As any scientist and researchers, you have to understand one needs to be built, one needs to be partner, one needs to raise commodity. And we find out that probably the most important thing that's missing is the infrastructure to connect the community of users, which are developers and data donors, and then application users. So what we decided to do is to create a surgical operating system. What the surgical operating system does, a few things. That's our bridge. It promotes ethical and trustworthy data generation, model development, and validation, benchmarking of those models, and assuring with ethical considerations. 4 major points to work with: data privacy, AI model development, validation of those models, and governance. This is the very, how can I say, high-level overview of the SAIIL SOS platform. Of course, there is a lot of proprietary information that we cannot be showing here. But you see all the different levels where it connects with. It goes from model development for model training, validation, market services, AI governance. It interacts with different stakeholders on the top and is cloud agnostic. The functional overview, if you see that each one of those people in purple, they are users that can connect inside of the network and the operating system to either generate data, generate AI models, and validate them. 2 core components. One is the data banking system, the other one is the model banking system, and they are separate from the metadata and the model cards. So going back to, I'm a huge Marvel movie fan, if you guys have not noticed that. But what if we can actually do this, and every single one of those nodes could be healthcare systems across the globe, or it could be single people just donating their data. It could be patients donating their data. It could be surgeons donating their data. And it could be just surgeons in rural areas using the applications that have been built. So the SOS, it promotes standardization, efficiency, and safety for surgery. Has all those features from scheduling, integrating different technologies, promoting secure access, doing analytics real time like the Formula 1 does, better user interface, collaboration through telementoring, telecommunications, and also can design unique applications. A few of them I'm going to show, but by promoting data generation and management that's AI ready, maintaining the same standards, everybody else can access this type of information to develop their models. Similarly for model developments, you can train the data, train the algorithms, test them, and continue learning and improvement as it goes on a daily basis. And of course, this will promote trustworthy, responsible, and ethical use of artificial intelligence. Besides that, it can connect different technologies, like have different robots for different vendors and different energy devices. They normally don't talk to you, like an Internet of Things. You'll be able to communicate them through APIs. And of course, giving the right security access to whoever needs the access for is paramount to this. In other words, where we're building a market for cognitive augmentation. It gives a much better information, guidance, and safety among what we can do in the surgery, especially operational efficiency. One of the models that we already have experimental phase is that it looks at the log probability that the events are happening during the case are occurring in the right fashion. And the colors are representative of that. So this is a visual representation of the log probability. This is a normal case. It's a laparoscopic sleeve gastrectomy where part of the stomach is being removed for obesity. And the system in the real time can see this, that is an absolutely normal case, generates a normal surgical fingerprint, and there was no deviations from the standard. But again, if we throw a curveball, which we did, where this patient had an open cholecystectomy, so the gallbladder was removed through a big open incision. So there is adhesions between the fat we have inside cavomento to the abdominal wall. We need to take them down before we can do the surgery. Because the machine has never seen this, it deviated. It saw that there was a deviation from the norm. So that's a huge potential with this type of technology right now. We published this paper in Annals of Surgery, and when we saw that every time there was a low log probability, abnormal things happened during those procedures. So what are the next steps? The next steps is to be very, very ambitious, because without this, we won't be able to be getting there. Is to be developing surgical video foundation models. It's similarly what happened with the large language models and the ChatGPT, who use large amount of information from the internet. But here it's going to be curated by surgeons who are training and getting the videos and making people understand what's happening in the operation. Will allow analysis, will allow prediction of complications, will allow real-time guidance of the operation, and of course, in the near future, automation for machines as well. Another thing is very interesting with this type of technology, if you work well with the foundation models, when you fine-tune them, you can use those techniques of the standardization to talk about deconstructing surgery in a temporal level and also deconstructing the surgery in a spatial level. It's called transfer learning, because many actions and many tasks we do in one operation can be translated to the other ones. And similarly, some steps of the operation are part of the other ones. Understanding inflammation in one part of the body, it can be translated to inflammation in the other part of the body. That's how when we are interns, we learn surgery. And also, it can allow us to do what Formula One does, benchmarking. They benchmark those cars, those technologies, their aerodynamics, the engines, the tires, every single thing, because it's being transparent. We're seeing what's happening. So we can actually then compare models from different vendors, from different hospitals, and see if they are trustworthy, reliable, ethical, but also are they accurate, and test in a real time, in a daily basis in our works. Also, one thing that's super important to understand is this, and everybody's going to talk, who is a CEO from companies here or director of hospital going to say, what is my return of investment, right? Why are you going to build such a magnificent infrastructure without getting the money back? But there are so many options, right? Data monetization. You can be generating videos, you could be generating data, and getting more income for your hospital to apply in the different areas. You're going to be working with model co-development of industry and getting revenue from that. You can develop your own models and put up for subscriptions like App Store, when you can download an application and pay for a subscription. You can also be contracted for clinical trials when you're mature enough at your site that you can critically assess if those models and the data are meeting all those checkboxes that I just mentioned. And of course, you can be doing pre- and post-market evaluation of applications and the quality of the data. So if we put all of this together, all those standards that we created and proposed, all the knowledge dissemination, understand the governance around it, and pass this to others and have people to embrace, what we can do is this. We can apply techniques such as this that we develop in our lab, and what it does is it looks back in the previous 15 seconds of the operation and make prediction what's going to happen in the 15 future seconds of the operation. And if we apply similar techniques that Oracle applied for Red Bull, for the analytics about air handling and recovery, we could potentially see something like this. Again, it's a similar case, it's a hypothetical case, but the machine will be able to identify the air before it occurs and would alert us, and this will never happen. This patient will have a normal surgical fingerprint, and they're going to go home. So I think we're very close to cross the chasm. I really encourage people from this region to collaborate with us with data, partnership, development, sharing the knowledge, and then we can build that bridge, we can cross this chasm. With that, always a huge thanks for our team, from our alumni and our SAIIL collaborators for this work to happen. Thank you very much.
Thank you so much, Dr. Meireles. I'm so glad I had that large lunch and watched all those videos.
Oh my God.
Can I ask, do we have any questions from the audience? Please raise your hand. Fantastic presentation. One of the questions I would ask is, in the world of healthcare, do you feel that that data is easier to get access to if people know what's happening with that data? Because obviously, 2,000 operations, when we look at a large language model, it's a lot, but it's nothing compared to what you need to get a really good, high quality model. Is it easier to get data of these surgeries when you present your premise? Yeah, so we learn a lot from the CVS Challenge. And what happened was, in the beginning, nobody wanted to donate the data because they didn't know what the data is going to be used for. It was until we created a right governance structure to assure them that's going to be using for the ethical reasons and for understanding, for like research, quality improvement, education, was a big change. Second thing was, when we build infrastructure, make it easier for them
to upload the video gets de-identified, and then we can use it. And then it just was like a massive, like an atomic effect, right? We're looking for 1,000 videos, we got much more than that, right? So I think the idea is that if you can build the operating system that allows people to go understand the terms and conditions, understand what is involved, understand what's going to be the use, makes people much more comfortable to do it. Then making easier for them to collect the videos makes it easier for them to do it as well. And I think eventually it's going to become like a massive effect. But people are willing, the patients are also willing, they want to see surgeries smarter, right? So it's going to be safer surgeries. The biggest roadblocks, I think, a lot of times the health systems, they get in the way with their, oh, we cannot do this because of the PHI. Our lawyers are not going to let it. It's not true. I mean, there is always ways to do things. But the problem is like with so many roadblocks, it kind of discourages people.
Obviously, your model worked that we saw with specific surgeries. Is the idea that this would be a standard operating system through which you would be able to train models on all sorts of surgeries, including retinal surgeries or you know, reconstructive surgery?
No, absolutely. I mean, the way this is being built for surgery first, in special GI, is because I'm a GI surgeon, right? But the idea with the especially
GI surgeons have the best videos, by the way.
We do. Because you have the technology, right? But we can translate this entire technology to others. It's easy. It's video-based, and once you have the video, you can do that. And not just that, it can go beyond surgery. It can go to radiology, pathology, cardiology, whoever uses this type of technology.
Is there a worry that while Duke is pursuing this particular platform, over in Stanford, they have their own particular platform, and the same in Oxford, and what we have essentially is everybody working on similar platforms because it's important for them to do their own thing, but actually the patients lose out because there's no standardization across these models, and everyone has a small bit of data instead of all of the data?
That's an excellent question, and it's absolutely true what you're saying. So the biggest problem is this. There are silos, right? There's silos within industry, and there are silos within academia. And then the idea of the SOS here is to break those silos. It's going to be agnostic, it's going to be API connection, right? For example, we have our own system at Duke. I came from a different institution, Mass General was a different system. Stanford has, many other places in the world has it. But they're not willing to collaborate because, first of all, it's hard, and it's not incentivized. Here, if you can start thinking about the benchmarking portion of it, how good is your technology compared to mine? And that's what we did at CVS Challenge. Yeah. Some people were very upset that they saw that they actually didn't do so well. And other people were extremely happy how well they were doing. And that's the only way to do it.
Yeah, and we see that across AI model development as well, right? We have all these models constantly competing with each other. It's a similar idea that once you have benchmarking, it sort of points a pathway to some sort of consensus that this is the best model. Is it going to be adopted though? Even if Stanford's model is not so great, might they still reject a model by Duke because it's not Stanford?
No, we could. And in general, right now, a lot of the places, they want to have their own technology, for example, their own data identification software. But it makes no sense because if you're like going in a future where you can benchmark everything and use the model cards and see what they are doing, like F1 does, right? One team launches something, immediately the other teams, oh, this is really working, want to go in that direction, right? And you see the costs are going down in sports.
Right.
You know, and the cars are getting faster and safer. It's exactly, Stanford won one of the sub-challenges over there for the CVS Challenge. And they have to publish the model cards. And then people are going to see, oh, if they're that accurate, I want to go in that direction. But then what happens is, next year, if you're not improving yourself, people are going to be catching up with you.
Yeah. And I you know, in this area of healthcare, if you are involved in hospitals or involved in healthcare, you know, finding a way to share that data for the betterment of patients is always a very noble thing.
Absolutely.
So it's been wonderful to have you on stage, and thank you so much for your time. Ladies and gentlemen, Dr. Ozanan Meireles.
Thanks so much.
Thank you.
Thank you.